So we've talked about vectors and what vectors are, and how a vector is just a quantity that has both a magnitude and a direction. And because of that, we represent vectors visually as arrows, something like this, or, it could point any direction. It could be some other arrow that points like this, has a different length, meaning it has a different magnitude and also may have a different direction. But to really talk about vectors, we need to choose a coordinate system. And so there's actually a rule that goes in choosing what coordinate system we use. So the coordinate systems that we use are right-handed coordinate systems. So what does this mean? Well, I've actually gone ahead and done a little drawing to help illustrate this, literally. So here it is. This is a hand that I drew. I know what you're thinking. This is like the most amazing masterpiece that you've ever seen, and I thought the same thing after I'd finished drawing it. But anyhow, this is supposed to be a right hand, in case that's not obvious. And this right hand shows us what a right-handed coordinate system is. And so as a side note, there are a lot of times in physics where you're going to be using your right hand to do what we call right hand rules, of making your right hand do some shape or some maneuver to help you visualize what's going on. So you'll get used to doing like a couple of these different tricks with your right hand, but here's one of the first ones. So this is for choosing a coordinate system, and to just keep in mind where the axes are supposed to point. So to do this, you just point your thumb straight up. You can like start with a fist and have your thumb pointing straight up, giving like a thumbs up, then point your pointer finger straight away from you. So you've got like a capital L shape between your pointer finger and thumb, and then take your middle finger and point it straight away from your palm. And so all of your fingers should be at 90-degree angles to each other. And the point of this is to give the directions of the positive axes of a right-handed coordinate system, right? So these are the axes. So your thumb is pointing in the direction, when you make this shape, your thumb is pointing in the direction of the positive x-axis. Your pointer finger is pointing in the direction of the positive y-axis, and your middle finger is pointing in the direction of the positive z-axis. So to sort of represent this a little more, with less pictorially like this, this is really what we're going for. So this is a 3D right-handed coordinate system, and it's a right-handed coordinate system just because if you make this shape with your right hand, you can sort of twist your hand around via your wrist until you get it so that your middle finger is pointing as the positive z-axis here, and your pointer finger is pointing as the positive y, and your thumb is pointing as the positive x-axis. So that's what we mean by a right-handed coordinate system. We mean that you can make this shape with your right hand, with your fingers representing the directions of these positive axes. So that's all a right-handed coordinate system is. And all the coordinate systems that we're going to be using are going to be right-handed coordinate systems. So that also brings me to another point that I would like to make, which is that oftentimes, we think that we're, only working in 2D. And so a lot of times we might have, you might just draw a coordinate system that looks something like this, where this is one axis, this is another, and then you say, oh, this is my positive y-axis. Whoop, let me stop drawing straight lines. This is my positive y. Let me actually draw a y. Positive y, and then this is my positive x-axis, right? And so, it looks like we're only working in 2D, and a lot of times we only are working in 2D, and so it's kind of helpful to draw this, but keep in mind that this is actually a right-handed coordinate system, and so there actually is a positive z-axis. And so to represent that, I first need to talk about just a little notation just for a sec. So when you have a vector that's pointing into the page, and you kind of have to get used to thinking of vectors in 3D, but if you have a vector that's pointing into the page, we represent it as a circle with a little cross like this, a little crosshair. And if we have a vector, like that, so this is into the page. And if we have a vector that's coming directly out of the page, we represent it as a circle with a little dot. And the idea behind this notation is that if you imagine a vector and you imagine it as literally being an arrow, the back end are going to be the feathers. And so if the vector is going into the page, it's going away from you, and all you see are the feathers of the vector. So that's why we have this little X in a circle. And if the vector is coming out of the page, it's coming right at you, and all you see is the tip of the arrowhead. So that's why it's a dot like this. So anyhow, to relate this back to the coordinate system where you think you're only working in 2D, there actually is a positive z direction and a z-axis, and so a negative z direction, of course, as well. And so I kind of want to leave it to you. I'll ask you a question, and of course I'll answer it. But from this coordinate system, right, which direction is the positive z-axis? And the trick to answering this question is to use that right-hand rule that we just talked about. So I'm assuming that you've, taken your right hand or maybe visually done it, but the positive z-axis here points out of the page, right? So, so it points out of the page like this. So this is the direction of the positive z-axis, and you just get that by using that right-hand rule. So that's kind of a point that I want to make, is that a lot of times you think you're only working in 2D, but there actually is a third axis, oftentimes the z-axis, that is going on in your problem. And another thing that I want to point out too is that even when you only draw the positive x and positive y directions like this, even that is still following the right-hand rule that I just described up above. Because if you make that right-hand rule shape, even if you ignore your middle finger, this coordinate system is still following that rule of the thumb pointing in the direction of the positive x-axis and the pointer finger pointing in the direction of the positive y-axis. And so I want to do a little more practice with this. And the reason why is because whenever you start working on a problem in physics, whenever the problem involves vectors, the first thing that you want to do is draw a coordinate system. Just pick a coordinate system. Once you pick it, then stick with it the entire way throughout the problem. So, and you always want to pick a right-handed coordinate system. So let's say that you picked a coordinate system and you decided to do the following with it. So there's sometimes where this is useful. So let's just do a quick example with this. So you've decided to pick that this is going to be your positive y-axis direction, and then this is going to be your positive x-axis direction. And I'm just going to do example 1 here. So where's the positive z-axis pointing? Well, again, it's out of the page, right? So, and again, you just get that by making that right-hand rule shape. And again, this is just a right-handed coordinate system, as all of the coordinate systems that we use are. And I'll just do a second example just to kind of hammer this home. So let's say that you had a coordinate system and you decided to, let's see, you made it so that, right, you did something like this. And let's draw it here. And let's say, for the sake of, let's say that you made this the positive z-axis, right? And then you made this the positive y-axis, right? So now tell me which direction the positive x-axis is in. And doing the right-hand rule above, you again get that it's out of the page. The positive x-axis in this problem is out of the page. So I just want to emphasize that when you're doing a problem, always start by picking a coordinate system. Always draw these axes. You don't have to draw the third dimension, the one going into or out of the page, if the problem doesn't require it. But I just want to keep it, it's important to keep in mind that even when you only draw the, like an X or Y axis, you're only talking about a coordinate system in 2 dimensions, it's still following that right hand rule. You're just ignoring one of the fingers of that right hand rule, even if it's only 2D. So anyway, and you can always rotate your coordinate system. You can take your right hand and swivel it about your wrist, and you can, so that's why you can rotate the coordinate system. You can do pretty much anything you want with the coordinate system you pick for your problem. You just have to keep in mind that coordinate system has to still obey the right hand rule, because we always are working with right-handed coordinate systems.